Hello, this video is the Conservation of Momentum 2, which is a follow-on from, of course, Conservation of Momentum 1. Now, in the law of the conservation of momentum, it says that momentum of the system is conserved unless acted upon by an external force. So, the opposite of external is internal. So let's think of something that has an internal force. Let's say a bomb. Now, if a bomb were to explode, there'd be lots of momentum flying all over the place, wouldn't there? However, let's think about this. What type of force is it in the bomb? It's an internal force. Now, the initial momentum of the bomb is in fact equal to zero. It has mass, but it has no. Well, let's say it's stationary. It has no velocity whatsoever. It's just sat there waiting for somebody to explode it. Okay. Now, I don't know why I draw an antenna on the top. No reason whatsoever. So, and after it exploded, of course, the bomb will feel an internal force, and all the fragments will fly off all over the place. And if you could calculate the momentum of all the bits and pieces by looking at where they landed, etc., etc., if you could to, you will find that the total momentum afterward, the final momentum of everything just after the explosion, the final momentum would actually be equal to zero, because due to the vector part of it, if you've got something with a positive momentum over there, it will be balanced out by something with a negative momentum. Okay, now that is a similar idea to firing a gun, which is far easier to calculate with any surety. So let's have a look at. Whoa, there you go, settle down now. Let's have a look at firing a gun situation, which uses the idea. So here we have a rifle. Oh, how am I going to draw this? Well, just about okay. And it's going to fire a bullet out of the end. Now, the initial momentum of the system, initial momentum of the gun and the bullet together will be zero. And the final momentum will also equal zero, because the bullet will go off in that direction and the gun will recoil in that direction. Okay, let's assume that the positive direction is in fact in that way. Okay, and the mass of the bullet is equal to 20 grams. The velocity bullet equals 200 meters per second. The mass of the rifle, say it's equal to 5 kilograms, and we don't know that, and the recoil velocity of the rifle is called V. That's what we're trying to find out. So let's set up an equation. So we have the initial momentum is zero. So zero initial momentum equals final momentum, and the final momentum is going to be 20 grams. We must convert that into kilograms, so that will be 0.02 kilograms multiplied by 200 plus the mass of the rifle, which is 5 times V. So this is our equation, and I'll rub things off here to make things a little bit neater. So rather like that. So 0 equals 0.02 plus 200 plus 0.2 times 200 plus 5 times the final velocity of the rifle. So therefore we have 0.02 times 0.02 rather, times 200. Okay, so we have 0 is equal to 4 plus 5v. So therefore minus 4 equals 5v, which implies that v equals minus 4 over 5, which equals minus 0. Equals minus 0.8 meters per second. So in fact, that is correct, because if this is the positive direction, the gun is recoiling in that direction, so and that is the answer. Okay. Now, the other thing we'll talk about is about the energy conservation within momentum. Of course, energy is conserved at all times, but we're looking at the kinetic energy, the conservation of kinetic energy, and we'll look at that in the next video.